Welcome back, folks, to Precalculus. Today we're in Chapter 1, Section 2, Linear Inequalities. So we're going to dive right into some vocab and talk about the set of all numbers that satisfy an inequality as being called the solution set. So the set of all numbers that satisfy the inequality, or aka the answers. Okay, to write a solution set, we use set notation. Okay, so for example, that is the set of all x's such that maybe x is greater than 3. Okay, set notation. Another way we write our solution set or all of our answers to satisfy an inequality is through a number line graph. A number line graph. So if I'm going to graph my answer that I have up here, I just use as an example, I would have the number 3 greater than, not equal to, and I would shade to the right. Okay, so you guys have done that many times. Last way is the most popular way that we're going to use this year, and that is through interval notation. Interval notation. So if we look at our number line here, or your set notation, whatever one you want to look at, I'm going to follow the same x greater than 3 answer. That just means all of the numbers from 3 to infinity, but not including 3. Okay, so we use a parenthesis when we don't want to include 3. We would use a bracket if we wanted to include 3. So like I just said, if the number is a solution, a boundary point, or endpoint, we use brackets. If the number is not in the solution, like 3 up here, then we use parentheses. Okay, this little symbol here that looks like an E is a symbol that x is an element of the set or interval. Okay, this little thing looks like a sideways 8 is a symbol for infinity, going all the way to the right or all the way to the left forever. Okay, lastly, a linear inequality. A linear inequality, notice we're not working with equalities today, we're working with inequalities, meaning there'll be no equal signs, okay, is written of the form ax plus b, and I'll just make one up, less than c. Okay, it could be greater than c, less than or equal to, where a, b, and c are all elements of the set of all real numbers. So there's that elements of from up here, symbol. Elements of the set of all real numbers, where this r with the extra line means the set of all real numbers. Okay, so let's slide down here to our first example and just recognize that with inequalities, it's the same solving process and properties as with equalities. Okay, so we got the property of equality. We can do things to both sides, etc., to get x by itself and isolate x. So here we go. So we got x plus 3 is greater than or equal to 5. So rather simple. We're going to subtract 3 from both sides. So we end up with x is greater than or equal to 2. So that's our answer. We're being asked to write this in set notation. So in set notation, our answer is x such that all x's have to be greater than or equal to 2. If we wanted to do it on a number line graph, I'll do it down here. Draw a number line, put our number 2. It is greater than or equal to, so we're going to include it. So it's going to be a closed dot, and we are going to shade to the right. Lastly, for interval notation, I like to look at the number line. I like to say, oh, because we read number lines from left to right, so we're going to read interval notation from left to right. 2 to infinity. Infinity never has a bracket because you can never touch infinity. And 2 is included, so 2 should have a bracket. Okay, so now we've got some examples here on the back. The first example, rather easy. We're just exercising the multiplicative property, multiplying both sides by -2. So we get -4 and -10. But keep in mind that when you multiply both sides by a negative or divide both sides by a negative, you always flip the inequality, which should make sense because -4 is bigger than -10. Okay, so now solving this one right here, we're just going to multiply both sides by 3. Get the 3's to cancel out, so we got 2x is less than 30, and divide by 2, so that means x is less than 15. So in interval notation, that would be negative infinity to 15. Not included because x is less than. Okay, dividing both sides by negative 5 here in our next example, x is less than or equal to, we've got to flip our inequality, negative 3. So negative infinity to negative 3 with a bracket. Okay, sometimes it helps if you want to, you can draw your number line on those last two examples, and the interval notation does become a little easier. So looking at these next examples, some of them are looking a little intimidating, but they shouldn't be. Okay, what we're looking at here is a bunch of fractions with a common denominator of 8. Okay, so all I'm going to do is take this whole thing and multiply it by 8, just to get rid of all those fractions. Okay, so negative 1/2 times 8 is negative 4, negative 4x, plus 5 times 8, 5/8 times 8, I'm sorry, is 5. And 3/4 times 8, 3 times 8 is 24, divided by 4, 6. Now it becomes a very easy problem to solve. Subtract 5 from both sides, so negative 4x is less than 1. And then divide by negative 4, so we're flipping our inequality and we get x is greater than negative 1/4. Okay, which is essentially our set notation. Our interval notation, or our number line way of showing our answer is greater than negative 1/4, so we're going to shade to the right and have an open dot. And our interval notation would be negative 1/4 with a parenthesis to infinity. So the next three examples I'm going to ask you guys to do on your own, okay? And then we can go over them in class if needed. But I do want to give you guys a couple bullet points about each one. So for number 2, remember you do need to distribute this negative sign. So it should be a negative 5x minus 3, and this should be a negative x minus 2. Okay, so just be careful with your negative signs. Down here, you probably want to get rid of your fractions. So you probably want to multiply by something to make those halves disappear. And same thing over here. You probably want to multiply by something to get that half to disappear. And remember, whatever you do to one thing, you have to do to everything. So good luck and bring your questions to class.